In the second part of this video on graphical user interfaces and event handling, we will discuss how to define custom colors and fonts and how to construct a GUI using nested panels. Two examples of programs will be used to illustrate these concepts. In creating GUIs, there are times when we wish to make various components colors other than the default of black. In Part 1, we mentioned that although the AWT package is no longer the primary source for the classes we use to build GUIs, there are still a few classes in AWT that were not replaced with classes in Swing. The color class is one of them. It contains about a dozen predefined constants for commonly used colors. By consulting the Java API, we can see what colors are defined. Notice that they are defined in both upper and lower case. The lowercase constants were the original ones. The uppercase constants were added in Java 1.4 to adhere to the standard lexical convention that constants should be written in all uppercase. For that reason, the uppercase constants should always be used. When predefined colors are not adequate, we can define custom colors by mixing RGB values. We specify the intensity of each of the three components with values ranging from 0 to 255. The values that can be specified by 1 byte. 0 is the darkest and 255 is the brightest. The color class contains a constructor that can be used to create a custom color in that fashion. Specifying all three values as 33 would give a very dark gray color, not quite black. Using 222 for both red and green gives yellow, not quite as bright as the brightest yellow. Keep in mind that light colors mix very differently than paint colors. Similarly, there are times when we would like to use a font that is different from whatever default font our platform provides. Like the color class, the font class is also defined in the AWT package. When creating a custom font, there are three characteristics that we must specify. The first is the font name or font family name. It is preferable to use logical rather than physical font names to ensure consistency across platforms. The logical names specify font characteristics rather than actual physical fonts such as Times New Roman. The second is the style, which can be plain text, bold, or italics. It is also possible to combine bold and italics. Point size is the third. This measurement originated with typesetting. It indicates how large the characters are. With the point measurement, 72 points is equal to 1 inch. There are two fundamental typeface characteristics. The first is whether or not the font has serifs. The font used most on this slide is Arial, which is a sans, French for without, serif font. The package name java.awt is written in Courier, which has serifs. Serif fonts are used most often in books because they help form a horizontal line, which makes it easier for the eye to follow a line of text. In some alphabets like Sanskrit, all the letters contain a horizontal line for the same purpose. Serif and sans serif are two of the logical font names that can be used when creating fonts. The second characteristic is whether the font is monospaced or proportional. Courier is a monospaced font because all letters use the same character width. Typewriters, because of their physical characteristics, always used monospaced fonts. We customarily use a monospaced font when displaying programs. In proportional fonts, the width is proportional to what is required. So an I is narrower than a W, for example. Monospaced is also one of the logical font names. This program illustrates the use of the Border Layout Manager and displays a collection of different labels with different fonts and colors. The color of the first label is set to blue, and its font is a 16-point sans serif bold font. There is one thing different about adding components to a container with a border layout. Notice that the constant border layout.north is passed as the second argument to specify that the label is to be aligned with the top border. Scrolling down to the code for the second label, it uses a custom color that is a dark red and a font that is 20-point serif italic font. It is added to the bottom border. Let's run it to see the result. Notice the effect of resizing the window. Using nested panels can help when we are creating more complicated GUIs. The Java class for creating a panel is JPanel. You should have noticed that all the classes in the Swing package begin with the letter J. That is to distinguish them from similar classes in AWT. For example, AWT contains a class named Panel. Like frames, panels are also containers that are used for grouping components. Because panels are containers, components can be added to panels in the same way that they are added to frames. Panels can be hierarchical, meaning panels can be added to frames, and they can be nested further by adding panels to panels. Just as the main frame has a layout manager, every panel can have its own layout manager. Using nested panels simplifies creating more complex layouts. We conclude with several other useful features that can be used in conjunction with panels and components. The first of these is borders. Panels can have borders, and those borders can be labeled. The second are tooltips. Components, primarily buttons, can have tooltips. A tooltip is a message that is displayed when the mouse hovers over a component. Anyone who has used a commercial program is likely familiar with this behavior. Tooltips are useful for buttons that contain abbreviated names or icons whose meaning might be unfamiliar to some users. This is our final example of a simple window class. It creates a more complete calculator GUI. It illustrates the use of nested panels to show how different layout managers on different containers can be used to produce the desired result. Much of the code is very similar to the calculator keypad from part 1. Because we are going to create a border around our nested panel, we need to import the subpackage javax.swing.border. Using a wildcard in the import statement before this one does not import nested packages, so this import statement is required. First, notice that we have created a panel called NumberPad and set its layout manager to be a grid layout. One difference in the code that builds the keypad here is that the add method is invoked on the panel NumberPad, so all the buttons are added to the NumberPad panel, not the window. Scrolling down to the remaining code in this constructor, notice that we also added two more buttons, a clear and a clear entry button, and associated tooltips with each of them, and added a labeled border around the keypad panel. We then set the layout of the frame to border layout and added a text field to the top and a keypad to the bottom. By using a nested panel, we are able to make the text field extend over the full width of the keypad. So let's run it and see how it looks. Notice what happens when the mouse hovers over the clear and the clear entry buttons. Again, remember clicking the buttons on the keypad still does nothing.